Hello, my dear students. I welcome you all to the another topic of laws of motion. Today we are going to study about uniform circular motion, Newton 3 laws of motion, and about momentum. Okay? So, what do you know about uniform circular motion or just a circular motion? That is something which is moving in a circular form. Now, if you see this diagram which is given in your book, you will see a square, and if you move in this square, you have to change the direction at each corner. So, how many corner you have to change the direction so that you keep on moving? 4 times, right? Now, another diagram, if you go, so how many direction you have to take to change? 5. Similarly there 6. Okay, and if you keep on increasing these sides, okay, the number of turns will also increase, right? And eventually this path will become a circle. So that is a circular motion in which you constantly change the direction, or any object which is moving constantly change its direction, right? We don't know that how many sides are there. It could be infinite sides because we won't be able to see, but you can understand from this diagram that if you keep on increasing the side, the eventually what you will get a circle. So in a circle, at each point, okay, the direction of the velocity or the moving object is changing. So which kind of velocity it is? Is it accelerated velocity or non-accelerated velocity? So if I tell you a body or an object is moving with 5 meter per second, so it is taking a turn again and again and its speed is maintained as 5 meter per second. So can you tell, is it an accelerated motion or it is a non-accelerated motion? I hope everybody says accelerated motion. Why? Because even though the speed is same, the direction at each point is changing. And if direction is changing, velocity changes. And I have told you, rate of change of velocity is acceleration. We all know that by now. So if direction is changed, velocity is going to change, and if velocity is changing, of course accelerated motion it is, right? Let's study this circular motion in little detailed. You consider a stone which is tied with a thread. You hold the end of the thread and start to move that stone into a circular direction. So if by chance the thread breaks, where the stone will fall? So the stone will be thrown off in the direction of the tangent which is perpendicular to the radius of that circle that was being formed by your hand and the stone. You can understand by this diagram, student. And in which direction it will be thrown? The direction in which it gets thrown off will only depend on its position at that moment, right? So it means that the stone moves along a circular path. The direction of its motion is changing every single point, right? Now, some forces I would like to discuss here. The force which is acting inside, okay, is the centripetal force, okay, and the outside force which is acting is centrifugal force, okay, student. So holding a stone with a thread in hand and rotating it. So you can see here the red arrow acting inward, showing inward, is centripetal, and the purplish one is centrifugal force. All right, now let's go to the Newton laws of motion. The 3 laws of motion Sir Isaac Newton has put forth. First law of motion is related to inertia. Student, you must have played tug of war, right? There is a rope in the center, and that rope has to be shifted either side, and that side wins the match, right? So what happens basically, if both the side is applying equal amount of force, the center rope will not shift in any either direction. But when one side has applied more force, the other side come and fall to that side, right? This is a match that you play in tug of war. So you understand from here that when the force was equal, nobody was able to pull that rope. But what if the right side more force is applied by joining some other team members, or maybe the force was more? So the rope will shift towards the right, and right side players wins the match. This is what we do in the tug of war, right? Similarly, Newton's first law also explains the phenomenon of inertia. Now, what is that? It is the inability of an object to change its state of motion on its own. Now here you can see a ball was there, a soccer ball, a football is there in the ground. It will remain there stationary until and unless somebody kicks that ball. Now the ball is in motion. So to stop its motion, something should be there. Some unbalanced force has to be applied. So, or something is there to stop it. So here, what is stopping the ball from the motion? It is the net, or it could be grasses, or it could be some other's player leg. It could be anything. So it tells you that an object continues to remain in rest or in motion until and unless any external unbalanced force act on it. Okay, so that is the Newton's first law of motion. Now coming to the Newton's second law of motion, if a force is applied on any object, that object will have some velocity and it will show accelerated motion, right? Because it can change its direction, it can change its speed, so it will be a accelerated motion. So we know that force equals to mass of the object into acceleration produced in that object. We can understand from here, students, if more force is applied, that object will move more to a greater distance. If less force is applied, it will cover less. You can see the broader arrow shows more force was applied, and hence that green color object move to greater distance. And down, if you see, the less force was applied, hence the motion of the object covered the less distance. So for more speed or more distance to cover, more force has to be applied. Okay, so this is known as second law of motion, where force is the product of mass and acceleration. In your book, it is also discussed about momentum. The rate of change of momentum is equal to the force applied to that object. Now what is momentum? Momentum is the product of mass and velocity of an object. That is, it is denoted by P, letter P, capital P, equals to m into v. M is mass and v is velocity. The SI system, its unit is kg meter per second, while in CGS it is gram centimeter per second. Now, defining the Newton's second law of motion on the basis of momentum, it says the rate of change of momentum is directly proportional to the force applied on a object, and the direction or the change of momentum occur in the direction of the force applied. So momentum is what? It is the property of any object when it is set in the motion. How it will be set in the motion? If any force is applied. Okay, so force, how much force is applied, that much will be the momentum of that object. That's why I'm telling it as it's the rate of change of momentum is directly proportional to the force applied, and the change of momentum will be in the direction of the force applied. That means if the direction of force is coming from left, the object will move in right direction, in forward direction, and vice versa. Okay, now look, I have tried explaining you second law of motion through momentum, where change in momentum is proportional to force. So if the body is in rest or in any motion also, the initial momentum will be the product of mass and its velocity. I have written here P, which is momentum, is product of mass and velocity. So initial velocity, it will be m into u, and final velocity, it will be v. Okay, what is the rate of change of momentum? Rate, wherever rate comes, that means it is asking with respect to time. So some time before the momentum was mu, and after a certain time the momentum has changed to mv. So it is change in the momentum upon time. Now we write final momentum minus initial momentum upon t. M is common, so v minus u upon t. Now from a back equation, you have studied student equation that I have derived. Okay, so v minus u equals to a. V minus u upon t equals to a, that is acceleration. So we can write p equals to ma. And this second law of motion tells that rate of change of momentum is directly proportional to the force applied. So in place of P, I have already written ma, which is the rate of change of momentum. From the definition you can see here, according to the Newton's second law of motion, rate of change of momentum is directly proportional to the applied force. So that definition I have written in mathematical form. While removing the proportional sign, you require one constant. This is known as proportionality constant, and its value is 1. So ma equals to 1 into f, that means it is f only. I have rearranged and I have written f equals to ma. So this is your second law of motion. Okay, you have to remember the definition. Rate of change of momentum is directly proportional to the force applied, and through that we get the second law of equation of motion, that is f equals to ma. So the first figure that I was telling you, the arrow one, more the force, more will be the velocity and the distance covered. Less force applied, less distance covered, and less velocity. Okay, now let's see the last equation of motion, or the Newton's third law of motion. In Newton's third law of motion, it states that force cannot act alone. Why? Force is a reciprocal action between the two objects. What does that mean? That means that forces are always applied in pairs, okay, and the action and reaction forces acts simultaneously. Both the reaction and action forces will not happen in one object. That means action will be shown by one and reaction will be given by another. As you can see in the picture I have posted here, a ball is hit to the ground. That is the action given to the ground. And what is the reaction by the ground? It bounced the back up in upward direction. So action by the ball and reaction by the ground. Here also see, when you step out from the boat, action is shown by your leg and reaction is given by the boat. The boat goes in backward direction because there was a push while going out of the boat from your side, right? Now if you look here in the third example, when rocket is launched, lots and lots of air fumes and smokes comes out. So that is the action of the smoke which is given to the earth. And what is the reaction? That reaction, that rocket moves upward, right? So the action by the gas or the smoke to the earth and the reaction on the rocket, so that it launches and it goes in upward direction. You must have played trampoline, right? I hope everybody. So what happens there? So what happens when you start to jump, okay, that trampoline sheet, rubber sheet goes down and it let you go up. So it gives you a reaction. What is the action that you do? That you jump on that trampoline, and the reaction that is given, that is it let you go in upward direction. Now what happens in this cannon? There is a cannonball which is bombed. So there is an action that is given, but what is the reaction? The reaction is the cannon also moves in backward direction. Also rifle you must have seen in movies and on TV. So because the weight of this cannon or the rifle is more, the reaction is not shown much, only a little shift in backward direction. The action force, that is cannon or the bullet or the firing that is shown, that has more velocity because the mass is less as compared to the cannon. Also here you can see there is a braced in the ground. That means to so that the cannon doesn't move from its place. So the three laws of motion has finished. What we saw, that I will revise you one more time. The first law of motion was based on the inertia. Anything that remains in rest or in motion will continue to be in that state of rest or in motion until unless any external force is applied. Second one was F equals to ma, which is also rate of change of velocity. Momentum is directly proportional to the force applied. And third, any action has equal and opposite reaction to it. The last topic that you have to study in this chapter is law of conservation of momentum, which says that when two objects collide, the total momentum before collision is equal to the total momentum after collision. That means two objects hitting each other, the before collision whatever momentum of those two body and after momentum will be equal. That I am going to show you with a small clip that I have added here. So just go through it and we'll finish the chapter. So let's just see how this law of conservation of momentum happens in an object A and B, which is having mass m1 for object A and m2 for object B. Initially their velocity will be u1 and for object B it will be u2. This is before collision. That means both have not hit each other till now. As you know, momentum is product of mass and velocity. So mass and velocity for this object, that is A, the momentum will be m1 into u1, and for object B it will be m1 into u2. Now after the collision, what will happen? The velocity with which they were having, it will change. So from u1 it will change to v1. Similarly from u2 it will change to v2. Also their momentum will change, m1 into v1, m1 m2 into v2. Now student, focus on this point. As Newton suggests, Newton's third law every action has equal and opposite reaction. When the collision is happening, so what is happening basically? The object A is hitting the object B or vice versa. So whoever is hitting is applying a force on that object. So in this case, a force F1 is applied by object A on object B. Similarly, the B will also apply equal force on A. So F2 is the force on A which is applied by B. So remember student, F1 force is for B because it is applied by A, and F2 force is applied on A by B. Okay. Force, we all know the formula. Force is equal to mass into acceleration. Also, if you see here, I have written F1 equals to minus F2 because we know the action and reaction both are equal. So this force I have written F1 equals to minus F2. Why? Because action and reaction both has to be equal. And why this minus sign? Because the direction between these forces are opposite to one another. F1 is acting on right side and F2 is acting on left side. That we all know, right? Now come to the formula. For force, I told you mass into acceleration. So this is the force acting on object B. So for B we have to consider. So for B, I have written the mass m2 and it is moving with the accelerated motion, that is a2. Similarly, F2 is acting on A. So for force, I have written for ma for A object and a1 for A object. Now in place of A, we know that acceleration is equal to v minus u upon t. So you have to mention it for first object or second object. So here I have mentioned v2 minus u2 upon t. Similarly for first object, v1 minus u1 upon t. Time is same, which will get cancelled. Here m2 into v2 and m2, because here minus u2, right? Here you see minus m1 into v1 will be plus, this is plus, this is in minus, so plus minus minus m1 v1. Now here minus and minus will become plus m1 u1. Okay, till here understood? Now see, just exchange the places so that the v1 should come at one side and the u1 should come in one side. So if you take this that side, the minus sign will go. So, and I have rearranged also because I wanted 1 to come first. So m1 v1, and this was there only, and see here student, it is now plus because changing the side, right? So m1 v1 plus m2 v2, and this has gone that side. So m1 u1 and m2 u2. Now if you understand, this is mass into velocity, mass into velocity, mass into velocity of object A mass into velocity of object B. This is after collision and this is before collision. This is momentum, right? Because mass into velocity is what? Momentum. So this is momentum for object A and this is momentum for object B, which is after the collision, and this is momentum of object A and this is momentum of object B before collision. So total momentum after the collision is equal to total momentum before the collision. Why I am calling it as total? Because here I am considering two objects, that is A and B, and their momentum I am calling it as total. So there, meaning the momentum of object A and B, the initial momentum, okay, if you do sum, it was coming to final momentum, that is after the collision momentum, which together it is of A and B object. So that tells you that total momentum before and after collision remains the same. How it is for energy? Energy is neither gained or neither lost. It is just conserved, right? So here, if something is getting increased, so something gets decreased or vice versa. That is why the total change in momentums remains the same. So this is it, students, about the conservation of momentum. So what will be the momentum of a gun and the bullet before firing and after firing? Similarly, can you tell me what will happen or what is the momentum while launching a rocket before the launch and after the launch? You can comment down below. Have a great day, students, and thank you for watching.